All right, good evening, children. Good evening, online students.
Good evening, ma'am.
Yeah, I've shared my screen visible to all of you.
Yes, ma'am.
All right. So now we are going to take up the introduction to the chapter volumes and surface areas. And we have these solids, cone, sphere, and hemisphere in our syllabus. All right, cone, sphere, and hemisphere. Cube, cuboid, and cylinder we are done with in 8th standard. So we're not going to revisit them now. It was a part of your syllabus. We used to, have cuboid, we still have cuboids and cylinders for 8th standard, and we used to visit them again in 9th standard. So now that's removed. So we have only cone, sphere, and hemisphere for 9th standard. All right. Okay. So you can see the representation here of a cone. This is called a right circular cone. Right circular cone, because this cone has a circular base. And it's a right circular cone because the height of the cone and the radius of the cone are at 90 degrees to each other. That's why right circular cone. Right meaning right angle, 90 degrees. Right angle, 90 degrees. So the perpendicular height of the cone and the radius of the cone are at right angles to each other. Okay, so the word right, circular because the base of the cone is circular. So right circular cone. Okay, so this one is a right circular cone. This is the radius of the circular base of the cone. This is the height of the cone, the perpendicular height of the cone. Okay, the perpendicular height of the cone. And this is the slant height of the cone, represented by the letter L. This one H, this one R, radius R. Okay. So radius of the cone R, small letter R, perpendicular height of the cone, small letter H, and the slant height of the cone, small letter L. Now these three, things, the radius height and the radius, perpendicular height and slant height, they are connected by a relation. Okay. And that is by Pythagoras theorem. So you can see that this is the hypotenuse. The slant height is the hypotenuse. So the square on the hypotenuse, L square, is equal to the sum of the squares of the other two sides, H square plus R square. L, H, and R are connected by the Pythagoras theorem. L square, L is the hypotenuse, H and R are the legs. So L square is equal to H square plus R square. Is a relation between L, H, and R by the Pythagoras theorem. All right. Okay. And this one is also called the lateral height of the cone. Mostly it's called the slant height. It's also referred to as the lateral height of the cone. Lateral. Okay. So see here, R is the radius, H is the perpendicular height or the vertical height, L is the lateral height or the slant height, and the relationship L square is equal to H square plus R square, which means L is equal to square root of H square plus R square units. All right. Okay. Now, how do you find the volume of the cone? Volume is given by the formula 1 by 3 pi r square h cubic units. Volume is always expressed in cubic units. Volume of cone is equal to 1 by 3 pi r square h cubic units. Curved surface area. Now, how many surfaces does a cone have? How many surfaces does a cone have? A cone has two surfaces. It has one curved surface and one flat surface. The circular face is the flat surface. And then you understand, right? That's the curved surface. Now, in the case of a birthday cap, in the case of a conical birthday cap, there's only one surface, which is the curved surface. the flat circular surface is missing. Because if that was there, then how will you put the cap on your head, right? And the circle irkadu. Supposing you are making, you're very good at you're very good at craft work, and in your holidays, you want to earn money. Okay, so you buy some chart paper and that glossy glass paper or whatever you call it, and you make birthday caps and you sell it to the the stationer near your house, and you earn your pocket money. So you want to be independent. So then how do you make that birthday cap? You'll you'll only build, or you'll only make the curved surface area of the cone, right? Will you cut a circular piece and stick it under the the conical surface, the curved surface? Will you cut a circular piece and stick it at the bottom? No, right? Then how will you put the cap on your head? Right? So it's not like that. So a conical birthday cap has only one surface, which is the curved surface area. It does not have the flat surface, the circular surface. You can see the circumference, the edge of the circle you can see. You can see the edge of the circle, but that surface is missing. The surface will not be there. But if you take, this firecracker, the flower pot, okay. So you light it here, no? You light it here. It's a night cracker. You light it here, and then goes up like this. The sparkles, they go up like this. So that flower pot, that one also has so a flower pot has both the surfaces. It has a curved flower pot. Don't mistake. No, I'm not saying the garden flower pot. I'm saying the night cracker. Okay, so which we burn during Diwali. So this one has both the curved surface and the flat circular surface. So supposing the question is, what is the amount of paper you would need? What is the amount of paper needed to cover this night cracker all over? What is this called? Flower pot. Okay, so what is the amount of paper you need to cover this night cracker, flower pot all over? Then you have to find the area of the curved surface area of the cone and the area of the circle. Because where will you stick the color paper? You will stick it in two places. You want to stick color paper all over this flower pot. So where all will you stick? You will stick it along the curved surface area and the area of the circle. So you'll have to find two areas here. Curved surface area of the cone plus area of the circle will give you the area of paper needed to cover this flower pot all over. But supposing you want to stick, a color paper along the surface of a birthday cap. There you will not, there you don't have the circular base. So no paper you can stick there. There is no surface, then what will you stick? Okay, so where will you stick the color paper? Only for the curved surface area. So the amount of paper, the amount of color paper or the glossy paper you need to stick in a conical birthday cap is equal to the curved surface area of the cone. CSA, or the curved surface area of the cone. You should not find the area of the circle because no circle is there. Correct? So that's the difference. Now, how do you find curved surface area? It's given by the formula pi RL. Pi RL, square units. Area is expressed in square units. Volume is expressed in cubic units. Total surface area. So we understand that, or we just understood that a cone has two surfaces. So the total surface area is the curved surface area plus the area of the base circle. Total surface area. Okay. So curved surface area plus the area of the base circle. So what's the CSA? Pi RL. Area of the base circle, pi R square. What's common? Pi R is common. Pi R common. Take out pi R common. So you will get L plus R. Pi RL plus pi R square. When you take out pi R common, you will get L plus R square units, or pi R into R plus L. into R plus L square units, whatever. Okay, so what do you see here? The relation between L, H and R is L square is equal to H square plus R square. That is by Pythagoras theorem. L is the slant height of the cone, H is the perpendicular height of the cone, R is the radius of the cone. Okay, then volume 1 by 3 pi R square H cubic units, volume. Then the curved surface area, CSA or curved surface area, which is this one. Okay, the curved surface area is given by the formula pi RL. Pi RL, like A, B, C, pi RL. Pi is 22 by 7 or 3.14. Okay, R and L. Pi into R into L. Pi into radius into slant height will give you the curved surface area of the cone. Total surface area, that is both the areas together, both the areas of the two surfaces put together. CSA total means what? CSA plus area of the circle. Yeah, so pi RL plus pi R square. When you take out pi R common, you in the bracket you have L plus R or R plus L. Both are fine. Pi R into R plus L or L plus R square units. So this is about all the formulae with respect to a cone. So what is perpendicular height of the cone also called? What is the perpendicular height of the cone also called? Vertical height. What is slant height of the cone also called? Lateral height. Lateral height. Okay, sphere. Okay, volume, sphere. Anything spherical is a sphere. Okay, volume 4 by 3 pi r cubed cubic units. So in a sphere, the height in a sphere, its height is equal to twice the radius. Now, this is the radius of the sphere. This is the radius of the sphere. This is also the radius of the sphere. And this is the height of the sphere. This is the height of the sphere. So the height of the sphere is equal to r plus r, which is 2r units. Height of the sphere is equal to, here, what is this? Radius. This is center of the sphere. What is this? Radius. This is center of the sphere. This is radius. So height of the sphere is the maximum height of the sphere. The maximum height of the sphere is here, this one. And what is that? R plus R. R plus R. 2R. And what's the radius of the sphere? R. Height of the sphere, R plus R, 2R units. Radius, R. All right. Now, in the formula, you will not find H at all because H is 2R, right? So, you can see that in sphere, all the formula is using R only because H is 2R. There is nothing like H there. H is 2R. There's nothing like, there is height of the sphere, which is 2R. So, because H is 2R, you will not find this letter H anywhere in the formula because that is 2R. Okay, so volume of a sphere is equal to 4 by 3 pi r cubed cubic units. Now, in a sphere, you cannot differentiate between curved surface area and total surface area. Both are the same. In a sphere, you cannot differentiate between curved and total surface area because there's only one surface area. There's only one surface area, which is the total surface area. So there's nothing like in a cone, you can distinguish, right? In a cone, that thing that, the one which is like this is the curved surface area, and the flat thing is the, the flat area, the area of the circle. These two put together is the total surface area. But which is the curved surface area? This one. This one is a curved surface area. This is the curved surface area, right? And if you take this one and the area of the circle together, then that's the total surface area. Because you can distinguish two different surfaces in a cone. In a cone, you can differentiate between the two surfaces, the flat surface, the curved surface. So the curved surface makes the curved surface area. If you, to that area, if you add the area of the flat surface, then it's a total surface area. That is the area of all the surfaces available is a total surface area. What is total surface area? All the area put together is a total surface area. But there's nothing like that in a sphere, right? You cannot say that this is the curved surface area. If I include this, then this is the total surface area. No, there's only one area, which is the surface area or the total surface area. Like in a laddu, all of us like to eat laddu, right? So you cannot say, no, like which is the curved surface area and which is the total surface area. You cannot say that. Okay, so total surface area or simply surface area is 4 pi r square square units. Height of the sphere is 2r units. Hemisphere. We'll come to this later. Okay. This also we'll see later. Yeah. Hemisphere. Hemisphere is half of a sphere is a hemisphere. Half of a sphere is a hemisphere. Volume 2 by 3 pi r cube. That is 4 by 3 pi r cubed divided by 2. So 4 by 3 pi r cubed, division becomes multiplication into 1 by 2. So 2 ones are 2 twos are. So 2 by 3 pi r cubed. It's half the volume of a sphere. Sphere is 4 by 3 pi r cubed, right? Hemisphere is by 2. 4 by 3 pi r cubed by 2. So divided by 2 meaning into 1 by 2. Okay, so you can see it's 2 by 3 pi r cubed. 2 by 3 pi r cubed cubic units is the formula to find the volume of a hemisphere. See, yeah, in a hemisphere, you can differentiate between curved surface area and the total surface area, right? Now, if you take the example of a cap, the cricket cap, leave that shade which comes in the front, leave that. Otherwise, the one that sits on your head is a hemisphere, right? Correct? The cap. Okay, we'll not take into account that flap which comes here. We'll leave that. That is there, but we'll just ignore it. We'll take into account only that part which sits on the head, which covers our head. So that's a hemisphere. So in that hemisphere, where is the material? Where is the cloth used to make the curved surface area? The flat portion, there is no the portion below is not covered. Like in a conical birthday cap, the base is not covered because you have to put the cap on your head. And if it's covered, then you cannot fit it in your head, right? So in the case of a cap, the bottom portion is left open. But you take the example of, okay, so when you take a laddu and you want to share it with your sibling or somebody into two equal parts, so you just cut it like this. Okay, so it's now you have half of the laddu with you. This is the laddu. And you cut this into two equal parts. Okay, because you need to share it with somebody. So now you have one part. No? So one part of the laddu is like this. One part of the laddu is like this with you now. So in this laddu, because laddu is, it's, like completely, it's like, it's a solid. It's completely packed. It's tight. So here you will find the curved surface area. And the bottom circle also is covered. It's not open, right? So here you can find two surfaces, like you can feel the two surfaces. In this half laddu, you can feel the curved surface area and you can also feel the circle below. You can also feel the circle below. You can run your hand. If it's a big laddu, like from Tirupati, okay, the big laddu, then half of that, you can feel that, the curved surface area and the, area of the base, which is a circle. So here, so again, a hemisphere has two surfaces, one curved surface area and one flat area, right? Which is the area of the circle. Yeah, so in some hemispheres, the circular area is missing. In some hemispheres, you will find the circular area. It depends on the object. So in the case of a cap, there's the material, this cloth is used only to make the curved surface area. In the case of a cap, where is the cloth used? Only to make the curved surface area. That circle, bottom circle, no material is used. Okay. Now, if you take a cork ball and cut it into two equal pieces, you take a cork ball and you cut that into two equal pieces. Or you can even take this example of a shot put ball, shot put. Okay, let's go with this cork ball. You cut that into two equal pieces and say you want to paint it all over now. You have one half with you. You have one half with you now. You have one half of the cork ball. You have one half of the cork ball. Now you want to paint this all over. Where all will you paint? It's a cork ball, so it's not a football. There's in a football, there's only air inside. There's only air inside, and if you cut it, yeah, the air escapes and the football loses its shape. In the case of a football, when you cut that into two equal pieces, because it's filled with air, it loses its shape and you cut it. In fact, when you just prick it, it loses its shape. So I'm saying a cork ball, which is tightly packed. So when you cut that into two equal pieces and say you have one piece with you, one half with you now, and you have to paint it all over. Where all can you paint? You can paint the curved surface area and you can also paint the bottom circle because there is material there. You can paint the bottom circle because it's tightly packed, there is material there. So you can paint, yes or no? Yeah. So in some hemispheres, you have two surfaces. In some, you have only one surface, which is the curved surface. Some hemispheres have only one surface, which is the curved surface area. Some hemispheres have both the surfaces. That is the curved surface area as well as the flat area, which is the area of the circle. Exactly like a cone. Some cones have only the curved surface area, while some cones have the curved surface area and that flat area, which is the area of the circle. Okay. So curved surface area, 2 pi r square. Total surface area, which is the curved surface area plus the area of the circle. So it is 2 pi r square plus pi r square, which is 3 pi r square. What is CSA? 2 pi r square. What's the area of the base? Pi r square, because circle. So total surface area is equal to 3 pi r square. All right. And in the case of a hemisphere, the height of the hemisphere is equal to its radius. In the case of a hemisphere, the height of the hemisphere is equal to its radius. In the case of a sphere, height is equal to r plus r, 2r units. Hemisphere, radius is equal to the height. Height is equal to the radius, right? R. Yeah, write the name of the chapter and take down all this. Yeah, images I'll share with you on WhatsApp. Completed?
No, ma'am.
Okay.
Completed, ma'am.
Yeah. Finished? Oh, you must draw the diagram also, children. You need to take down whatever you see on the screen or on the board. Yeah. 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 Online children completed. Okay. Now take down this also, but we'll discuss, when we take up questions related to a spherical shape, but just make a note of the formula now. What happened, Sachin? Yeah, completed. Online children?
No,
Yes, ma'am.
ma'am.
Okay. Here, all of you? Still working? Still writing? Okay. 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 Done, Surya? Diagonal. Shiv Shankar, right? This is not W. This one. This is W. This is small r. This is capital R. From here to here is small r. Okay. Sit with your back erect. Go back and sit. It's not a lounge. It's a classroom. You're like imagining you're flying from Sri Lanka to India. No, no. You're already here. Sorry? Oh, you didn't go to school. You couldn't attend school. Oh, yeah. This is W, children. W. Small letter W, actually. This is small letter W. So we have to write this. This is a new slide. Width.
Yes, ma'am. I didn't complete the previous slide.
Oh, okay. 1 second. Yeah.
Yes, ma'am. ma'am. I think some students are.
Completed?
No, ma'am.
Okay. Okay, if we have to still complete the diagram portion, I'll share the image on WhatsApp. Can we finish it later? Okay, no, I'll just wait. No, it's okay. Finish it, children. Finish it.
Yes, ma'am. I completed.
Okay.
Done, ma'am.
All right. Very good. Okay. Okay. Online children, is my screen visible?
Yes, ma'am.
Yes, ma'am.
Online children,
Yes, ma'am.
Gayatri, Harsha, Jayant, and
Yes,
Shreya,
ma'am.
am I not audible?
You are audible.
No, ma'am, you're audible. The screen's visible, ma'am.
Sorry, my speakers were on mute. Yeah, am I audible, children?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay. Okay, let's take this question. A cone of height 24 centimeters has a curved surface area of 550 centimeters square. Find its volume. Okay. So what's the height of the cone? 24 centimeters. If it's just height, it's always perpendicular height, h. Because with in a cone, we have two heights, right? We have one perpendicular height, the other slant height. If it's just given height, it's always perpendicular height. Okay, so h is 24 and CSA is equal to 550. So with this, we have to find the volume of the cone. What's the formula to find the volume of a cone? 1 by 3 pi r square h. So you need the values of r and h to find the volume of a cone. This is the formula. 1 by 3 is 1 by 3. It's a constant. Pi is 22 by 7. So you need the value of r and the value of h to find the volume of a cone. Now, what do you know? You know h, but you don't know the value of r. So we have to find r using the information given. The question is to find the volume of the cone, right? What are the two values you need to find its volume? R and H. You need the value of R and H. You know H is 24, but we don't have the value for R. So we have to find the value of R using the information given. You cannot directly write volume is equal to 1 by 3 pi r square h, and no, you don't have the value of R. So first find the value of R. and then find the volume of the cone using the formula. Okay. So we given H is equal to 24 centimeters and CSA is equal to 550. Okay, now let's work with CSA. CSA is 550. What's the formula to find the CSA? Pi RL. Pi RL is equal to 550. Okay, what's the value of pi? 22 by 7 into R. R is not known. R into L is equal to 550. R we don't have, right? And L also we don't know, is equal to 550. So now what happens here is, this is one equation, but we have two unknowns. We have no other information. We have no other information, right? And in this equation, we have two unknowns, R and L. So we know in one equation, when you have two unknowns, you cannot find any value. With one equation, if you have one unknown, you can find the value of that unknown by solving that equation. One equation, two missing values, you cannot find anything. So now what you should do is, you must write L using R. That is, you must do some change with the equation so that there's only one unknown. That's all it is. Now this equation, we have two unknowns. Now we cannot solve and find the value of any of them. So what you should do is, you must do some change and make this equation have only one unknown. So for that, what we do, 22 by 7 into R into, what is L? L is equal to square root of H square plus R square. Okay, we have that relation. We have written that earlier. L is equal to root of H square plus R square is equal to 550. So 22 by 7 into R into square root of, what is H square? 24 square. 24 square. Into R into square root of, what is it? 24 square plus R square is equal to 550. Correct? Okay. So now look at the equation. There's only one unknown, no? R. There's only one unknown R. Whether it is R or R square, whatever, there's only one variable R there. That's it. Now we have to get rid of the square root symbol. We have to get rid of the square root symbol. So what you should do, you should have that expression which is under the square root on one side and take the others to the other side. All right. So see, we have, or you can do this also, R into square root of, what is 24 squared? 576 plus R square is equal to 550. 22 by 7 becomes 7 by 22, right? On the other side. See, R into square root of 24 square. 24 square is 576 plus R square is equal to 22 by 7 on the other side. 7 by 22. So now 22 ones are, 22 twos are 44. 11 remains 5 times. Okay. Or you can simplify using the tables of 11 first. See, you can simplify using 11. What is it? 11, 2 times 11. 5s are 55, 50 times. Then 2 ones are 225 times. Now, we have R into square root of 576 plus R square is equal to, what's 20 into 7? 175. Now square on both the sides. Square on both sides, or squaring on both the sides. We get R into square root of 576 plus R square. The whole square is equal to 175 square. Correct? Now, what is this? R square into 576 plus R square is equal to 175 into 175. 30625. So 576 R square plus R to the power 4 minus 30625 is equal to 0. R to the power 4 plus 576 r square minus 30625 is equal to 0. Okay. So what is it? Pi RL is equal to 550. We do not know the value of R, we do not know the value of L. So this is an equation with two unknowns. And we know when we have one equation with two unknowns, we cannot find any value. Okay, we cannot find the value of any of the variable. So what we do, we write L as root of h square plus r square, because L is equal to root of h square plus r square. So we write L as root of h square plus r square. And we have the value of h, right? H is 24. So now this equation, when you do that, you see that this equation has only one unknown r. Now the next task is to get rid of the square root symbol, for which we square on both the sides. The first task was to, the equation had two unknowns, so we had to do something so that it has only one unknown. That was the first task. Now the second task is that square root symbol. So we square on both the sides to get rid of the square root symbol. Now we have, what kind of an equation is this? It's a biquadratic equation, because you see you can see that the highest power of the variable r is 4. So it's a biquadratic equation. You can solve it like you solve a quadratic equation by splitting the middle term. You can solve this like you solve a quadratic equation by splitting the middle term and find the two values of r. Okay, it's time. I'll leave you with this, but you just write on and then we can stop. Yeah, so now you'll have to solve this like you solve a quadratic equation by splitting the middle term. So you'll get two values for r. I'll leave the negative one. Mostly one will be negative. So leave the negative one. Go with the positive value for r. And then you'll have to find the volume. 1 by 3 pi r square h. Yeah. Please take down the question as well as the answer to the extent we've worked and complete this by the next class. I told you how to go ahead. Solve by splitting the middle term, like you solve a quadratic equation. Completed? Yeah, if you finish writing, you can leave. Thank you. You haven't taken down the answer, is it? Yeah, please write the answer, yes. Done, Anita? Yeah, okay, you can. Thank you. Bye. Yeah, you can leave. Thank you.
Mom, I completed.
Yeah, thank you, Gayatri. You can leave the meeting.
Thank you.
Yeah, see you.
Ma'am, I've completed, ma'am.
Yeah, thank you, Shreya. You can leave the call.
Thank you, ma'am.
Thank you. Just one second.